Hey guys, the diagram shows a simplified representation of the human circulatory system entering and leaving the heart. Length of blood vessels A to D.
These came back from a search.
Okay guys, A is the vena cava because it's coming back from the body. So you can see this is coming back from the body into through A, and A is the vena cava. B is on its way to the lungs, so it's going to be pulmonary artery. C will be the pulmonary vein coming back to the heart, has to be a vein. Okay, and finally D will be the aorta because it goes to all parts of the body. Okay. Aorta. Right, let's keep going. Oh, we got more down here. Photograph shows one method of which the student can measure her pulse. What's the average pulse rate for an adult at rest? It's about 70 beats per minute, 70 BPM. I remember that from an old American scheme. Explain what exercise results in increased blood pulse rates. More food and oxygen are required by the cells of the body. The body to make energy. Hence, the blood has to travel faster. Okay. Now, let's continue on here. Diagram shows a student smelling an unknown substance in a test tube. Name one safety precaution been taken by the student in the diagram. Well, she's using the tongs, which are like the scissors holders. She's also wearing gloves. She's wearing safety gloves. She has a white jacket or a science coat. Okay, or a lab jacket. Give one safety precaution not been taken by the student in the diagram. I don't see any goggles on her. So, safety goggles. Okay. The arrangement on the right is used to separate water-soluble ink. Why is the position of the ink spot important? So that the water dissolves it and brings it upwards. Brings it upwards. Okay, so what I'm basically saying there, guys, if you imagine this like a wave front, this line I made here, what happens is the water level rises up through the paper, and what it does is dissolves the black. See the way I'm rising this up? It takes the black dot and brings it up the chromatography paper, or sorry, the filter paper with it. What happens is it dissolves the ink spot and then brings it upwards. So if it's a mixture of inks, it will come out in different colors at different times up along the top, something like this. Like sorry, my fault. Something like this. Like it comes up a mixture of different inks up the page, right? On the diagram, draw what you expect to see if the ink was not a mixture. Well, if the ink is not a mixture, it's just going to be all one color. It's just going to be black. And you can sort of see, you could have it like this, black ink. Or it should just come out as one or a dot. It should actually come out as one or a dot because it's all the same ink and it comes out at the same time. Yep, a sample of pure ink of one color would be something like that. Okay, a mixture would be more of a line of different colors on it. Okay, if Friday materials can be classified as acids, bases, or neutral using the pH scale. What is a pH scale? A scale from 1 to 14 to measure the acidity or basicity how strong an acid or how strong a base is of substances. Can an indicator of litmus paper be used to find the pH of a substance? No. It is only used to classify it as an acid or base. A substance as an acid or base. So it doesn't tell you how strong an acid or a base. Also, what litmus paper does is blue litmus paper turns red in acid or stays blue in base, and red litmus paper stays red in an acid but turns blue in a base. But it doesn't tell you how strong the acid is, so that's why it can't do it. Okay. Name 2A. I think we have an incisor there. State the function of 2B. 2B is a molar, so it's used to grind and chew food. Diagram shows the human male reproductive system. Okay, name A. A is a sperm duct. Identify the type of cell produced at B. Sperm cells. Okay. The diagram shows the human digestive system. Starch is broken to maltose. So starch is a long sugar chain. And what happens is it gets broken down into smaller double units called maltose. Okay. Identify the enzyme and substrate from underlined words. The enzyme is the amylase, because that's the chemical that breaks down the food. And the substrate is what it works on. So just better check that actually. The substrate is the substance that the enzyme acts on. So in this case, it'll be starch. Amylase acts on starch. Okay. Now, the photograph shows an ultrasound scan of a developing fetus in a womb. The number of events in relation to human reproduction occur after the production of gametes and growth of the fetus in the womb. Three of these events are ovulation, fertilization, implantation. Explain the underlying terms. Ovulation is when the egg is released from the ovaries. Can't remember how to spell released right now, so hopefully I do. The ovaries. Fertilization is the fusion of the sperm cell with the egg. Basically when the sperm cell joins the egg and becomes zygote. Okay, something like that. Where in the human female reproduction does implantation take place? In the uterus. It's where the embryo attaches to the lining of the womb or the lining of the uterus. Okay. All right, let's keep going. This is a good question, guys. So what we have here is we have 4 different salts, and the 4 different salts are being dissolved in solution. Okay. So what we can see here is that we have NaClO3 starts at 080. So it means that at 0 degrees you can dissolve 80 grams of it in 100 grams of water. Then at the very end, at 100 and what's that? It's just above 100. It's 100 and 110. Oh, it goes up in 5. So at 105 degrees, we can dissolve 240 grams of this one. All right, the next one is the KNO3, which I'll do down here. It's roughly at 0 degrees. It's roughly about 8 grams of this salt can be dissolved in water. But at the very end, you see at 100 degrees, you can dissolve 240 grams of it. So it actually ends up better than the NaClO3. KBr, which I'll do in red, is 0.60. You can dissolve 60 grams of it at 0 degrees. And then by the end, let's say 110. So it's about 125, 130, 135 degrees. You can only dissolve 120. So you can see how that works there. And then finally the last one, which is the sodium chloride. Not really much increase here. I'll do it in purple. At 0 degrees you can dissolve just above 30, so we call it around 33. And then at the very end, which is 135 degrees, you can dissolve 40. So you can see that although you went up 135 degrees, there's not much more salt you can actually dissolve there. Okay, so that's an interesting one. So let's look at the questions. What conclusion can be drawn about the graph about the solubility of NaCl in water as temperature increases? The solubility remains roughly the same. Now, what I say is roughly the same is it's a relatively straight line, straight across, with only a marginal increase. A marginal increase in solubility. As temperature rises. Okay, I was fine, I can never fit my answers in. Now, from the graph, identify the substance that has the greatest solubility at 60 degrees. So at 60 degrees, which one's the tallest? So what we're going to do is we're going to draw a line straight through 60, and whichever line we hit last has the greatest solubility. We already hit NaCl, we already hit KBr, we already hit KNO3, so it's the last one, it's NaClO3. So NaClO3. From the graph, identify the substance that has the lowest solubility at a temperature of 10. So we got to go to a temperature of 10 and go up. It's NaCl all day long. That's the first one we hit. So NaCl all day long has the lowest solubility. Describe the relationship between solubility and temperature shown for KBr. KBr solubility increases steadily as temperature increases. See the way it's pretty much a straight line, and it's increasing proportionally to the temperature. Straight line means they're in proportion, okay? So its solubility increases steadily. Now, the reason why I'm allowed to use the word steadily is because it's a straight line, or in proportion to the temperature of the solution. So the hotter the solution, the more KBr that you can dissolve. Are the substances shown ionic or covalent? Explain your answer. Now, you guys haven't done this before, okay? So basically, if you see the likes of oxygens, if you see oxygen, chlorine, bromine, chlorine again, if you see them mixed with sodium, potassium, and you see like a chlorine, an oxygen, or a bromine mixed in, they're definitely ionic. But you guys won't have done that, okay? You can say sodium and potassium. Actually, sodium or potassium chemically combined with chlorine, bromine, what was there another one, was there? Yep, chlorine and bromine are usually ionic, are always ionic, excuse me. Okay, good. All right, let's move on. Components, bulbs, and electrical circuit can be connected in different ways. How are the bulbs in the headlight connected? Well, these are going to be in parallel. And the reason why they're in parallel is that when one bulb fails, call this bulb A and this one bulb B, when one bulb blows up or doesn't work anymore, like so, the electrons can still make it around the other circuit. So the electrons can still go around the outer circuit even though the inner circuit is blown. So the fact that they can complete the loop on the outer circuit means that the headlights are connected in parallel. Give a reason why this mode of connection is used in car headlights, because it's important that both lights don't stop working at the same time. That one light breaking doesn't stop the other light from working. Okay. All of the bulbs in an old Christmas tree, when all of them go out when one of them goes out. Okay, so essentially what I can say here is that imagine I had one battery, like so, and I connect them all in series. So you'll see what I'm doing in a second. So here is my circuit with the battery diagram. And then what we're going to do is we're going to put a couple of bulbs here. 1, 2, 3, and 4. Now, if one of them stops working, the problem is the electrons have to go through all the circuits. So it has to go through all 4 bulbs, and all 4 bulbs light up. However, if one of the bulbs encounters a problem, we'll put a problem on the second bulb. There it is, no longer working. The problem is the electrons can no longer get through. This means that the electrons cannot complete the circuit. That's why they all go out. So they're connected in series. Explain why then one bulb blows, they all go out. The circuit is broke. Circuit is then broken. Electrons are unable to travel around the full circuit. Okay. A student used equipment to separate water from a sample of seawater. Name the piece of equipment. Alright, this is a distillation. Oh, sorry, I get it wrong. That's a Liebig condenser, so you can say condenser jacket. I always call it a Liebig condenser. Old school. What is the function X in the experiment? X is a cool water jacket, so essentially turns water vapor into, it turns gaseous water, turns gas water, gaseous water, or water vapor back into liquid water. Okay, what's the general term in the liquid of the beaker called? I think it's called the distillate. It's the substance that it's the liquid you want out of the mixture, and in this case it's water. Okay. The temperature shows the equipment used to investigate the temperature on the sugar, solubility of sugar in water. Identify the solute and solvent. The solute is the sugar, because you're dissolving that in the solvent, which is the water. Distinguish between a dilute solution, a concentrated solution, and a saturated solution. So dilute solution is only a small amount of solvent or solute in a large amount of solvent. Now, a concentrated solution is not saturated, so what we're going to do with the concentrated solution is say contains a large amount of solute compared to the maximum it could dissolve. So a case like that, a concentrated solution would be like, imagine if you could dissolve 100 grams of salt per 100 milliliters of water, and you are around 80. 80 would be considered a concentrated solution, but not saturated. And finally, saturated solution is a chemical solution containing the maximum concentration of a solute dissolved in the solvent. So it means you cannot dissolve any more solute in that solvent. Okay, that's saturated solution done for you as well. Let's move on. The photograph shows a pair of rollerblades which are designed to reduce friction on the ground between wheels. Friction is a force when two objects rub against each other. It always acts in the opposite direction to the motion. So what I mean by that, guys, is that friction slows you down. Okay, so if you're rollerblading and you're traveling to the right, the friction force slows you down, is actually pushing to the left. Okay, name one design feature of rollerblades that helps them to reduce the effect of friction. It'd be the thin wheels. Thin wheels reduce the contact area. So mountain bikes, lad, you notice, have big, broad tires. That's for lots of grip. While like racer bikes will have thin wheels, which is for less friction to slow you down. Okay, that's us, guys.